Greetings, and thank you for joining us on Sleep Science Top 1. This evening, we shall explore one of the most remarkable realms on our planet, the domain of bugs and insects. A concealed civilization unfolds, reaching from the depths of the forest floor to the very brink of the sky. Ancient and countless, they exist beneath every leaf and within every breath of air, laboring in silent unity, crafting the world in subtle ways that often go unnoticed, yet are essential to our very existence. Their role in pollinating the food we consume, recycling the remnants of forests, and creating vibrant patterns of movement and color is invaluable. Some illuminate the darkness, some cultivate their own fields, and others find their way by the constellations. In that world, strength manifests in countless ways, while intelligence often dwells in the most unassuming of minds. If these serene journeys resonate with you, consider liking, subscribing, or sharing your thoughts below. It guides others on their journey here as well, one weary spirit at a time. Yet, at this moment, the only requirement is to simply breathe. As the eyes begin to droop, the serene realm of fluttering wings and hushed murmurs envelops one, guiding them into a slumber that is gentle, enchanting, and tranquil. Let us commence. More insects inhabit Earth than there are stars scattered across the Milky Way. The vastness of insect life is truly unfathomable. It is estimated by scientists that quintillions of individual insects are alive at any given moment, a figure so immense that it surpasses the stars in our galaxy. Within each patch of soil, among every fallen log, and carried by every warm breeze, they flourish in infinite diversity. Every handful of earth could conceal countless hidden lives, bustling, consuming, constructing, and reshaping the planet, grain by grain. Insects vastly outnumber humans, with a staggering ratio of billions to one, and their collective weight once matched that of all other terrestrial animals combined. They do not merely serve as a side story of life on Earth. Rather, they form its very foundation. Their presence serves as a poignant reminder that the fabric of the world is woven not by the mighty and influential, but by the humble and tenacious, laboring silently together across the globe, unnoticed, yet undeniably powerful. Ants exist within colonies that operate as cohesive superorganisms. The unity of ants is truly astonishing. A colony may encompass thousands or even millions of individuals, yet it operates as though it were a singular, living entity. Every ant plays a distinct part. Some gather food, while others nurture the young. Some stand watch at the entrances, and others attend to the queen. No individual ant leads the others. Rather, they convey their messages through scent trails and chemical signals, creating a vibrant network of coordination. Upon the discovery of food by a single ant, the entire colony springs into action. In the face of peril, they unite seamlessly. They collaboratively construct expansive subterranean cities, featuring complex networks of tunnels and chambers, all meticulously ventilated and arranged. Their collaboration mirrors the remarkable efficiency of the human brain, with each ant functioning like a neuron within a larger intelligence. Observing them reveals a shared awareness, timeless and exact, serving as a testament to the notion that unity can wield power equal to that of sheer force. Some butterflies experience the essence of the air through their feet. The realm of a butterfly is influenced not just by the hues and illumination surrounding it, but also by the unseen chemistry present in the air. Upon their slender legs rest delicate receptors, capable of sensing the faintest hints of nectar, sap, or the chemical signature of a host plant. As a butterfly alights on a leaf, it delicately samples the surface with its feet, assessing if it is the suitable spot to deposit its eggs. This remarkable sense is so acute that a butterfly can perceive sugar dissolved in water at concentrations as faint as just a few drops in an entire swimming pool. For them, every surface carries a narrative, revealing what it presents, concealing what it guards. and hinting at the life that may emerge from it. Their wings serve the purpose of beauty and flight, while their feet are designed for understanding, intricately linking them to the world around them. Each landing unfolds as a dialogue with the terrain, expressed through the unspoken dialect of chemistry. Dragonflies possess the remarkable ability to perceive their surroundings from almost every angle, nearly 360 degrees. In a realm defined by constant movement, dragonflies thrive. Their vast, compound eyes encircle their heads, each one housing tens of thousands of lenses. This provides a sweeping perspective so thorough that they can monitor activity in almost every direction simultaneously. Colors beyond human vision, including ultraviolet light, are visible to them, and they perceive motion with astonishing precision. To a dragonfly, the wingbeat of a mosquito is not merely a blur, it reveals a visible rhythm, a pattern that can be anticipated and intercepted in the air. Their hunting success rate ranks among the highest in the animal kingdom, attributed to their nearly predictive vision. It enables them to anticipate the location of their prey before it arrives. Observing a dragonfly as it zips across a pond reveals a remarkable display of precision in motion, shaped by an age-old design that positions them as some of the most adept aerial hunters to have ever existed. Beetles account for a remarkable 1/4 of all recognized animal species. The narrative of life on Earth can nearly be recounted through the lens of beetles. With over 400,000 described species, each one showcases a unique adaptation to its environment. Some shine like precious gems, others are constructed with formidable strength, and a select few inhabit environments where nearly all other life struggles to endure. Their diversity is so staggering that when a scientist once inquired about the reason behind nature's creation of such a multitude of living things, another responded, half in jest, that the creator must have possessed an extraordinary fondness for beetles. They navigate through the earth, slip under the bark, swim in the depths, and consume a wide array of substances, from pollen to dung to decay. Their armor-like shells and intricate wings have captivated the imaginations of artists, engineers, and even those in the field of robotics. Each beetle, regardless of its size, holds a fragment of the planet's narrative, a testament to resilience etched in chitin and hue that spans hundreds of millions of years. The bees engage in a mesmerizing dance, conveying their messages even in the absence of light. In the hidden dusk of a hive, bees communicate the geography of their realm through the dance of their movements. A worker bee, having discovered a fresh patch of flowers, returns to the hive and initiates a dance upon the honeycomb. The rhythm of her movements, the orientation she adopts, and the pace of her undulating form communicate to her sisters the path to take and the distance to cover. This form of dance communication stands out as one of the most intricate methods of interaction within the animal kingdom. Surrounding her, other bees extend their antennae, seeking to sense the rhythm and interpret the message conveyed. They navigate together, relying on the sun's position, even when clouds obscure it from sight. Every dance embodies more than mere information. It encapsulates purpose, sustenance, survival, and the very heartbeat of the hive. In the shadows of the comb, a dynamic geometry unfolds, rich with motion and significance, crafting a dialogue expressed solely through movement. Fireflies produce light through a remarkably efficient chemical reaction. When a firefly glows, every bit of energy is utilized without any loss as heat. The light emanates from a reaction involving oxygen, calcium, and a compound known as luciferin, all harmoniously conducted within the small lantern of its abdomen. This reaction achieves complete efficiency, a feat that remains elusive for human technology. The dance of a firefly's light serves as both a means of connection and a ritual of attraction, a secret language that can draw in a partner or deter threats. In certain locations, multitudes assemble in perfect unison, illuminating the woods like a pulsating galaxy. Every flash serves as a subtle hint of biochemistry, transforming existence into a beacon of light. For millions of years, they have illuminated the warm air of summer nights, tiny alchemists, transforming simple molecules into brilliance, serving as a reminder that even the smallest beings can possess the key to nature's greatest wonders, refined creations. In the intricate world of nature, termites construct remarkable structures of clay that serve as air-conditioned cathedrals. Termite mounds stand as remarkable examples of living architecture, dynamic structures that expertly regulate air, heat, and humidity with incredible accuracy. Some towers soar to heights greater than a person, yet each chamber within is meticulously attuned to the needs of the colony. Warm air ascends through the vents, while cool air seeps in from below, allowing the mound to uphold a consistent temperature even beneath the scorching sun. Each termite may lack comprehension of the overall design, yet in unison, they construct as if directed by a shared intuition. The design showcases remarkable efficiency, prompting engineers to draw inspiration from termite mounds for the creation of self-cooling buildings. Within the confines of the colony, a solitary queen can produce thousands of eggs daily, as the diligent workers nurture both the fungus gardens and the developing larvae. The mound transforms into a dynamic entity, harmoniously poised between disorder and structure, fashioned solely from soil, saliva, and the passage of time. It stands as one of nature's most magnificent architectural wonders, crafted by beings no larger than a grain of rice. Certain wasps transform other beings into living vessels for their offspring. Among the most peculiar behaviors in the insect realm is the strategy employed by the parasitic wasp. A female discovers a caterpillar or spider, delivering a precise sting to paralyze it. Before laying her eggs within, the host endures, trapped in a state of helplessness, serving as a living cradle for the larvae destined to emerge from within. As they develop, the young feed with caution, steering clear of essential organs to ensure their host remains alive until the moment of their emergence. It presents a haunting yet extraordinary exhibition of evolutionary accuracy, showcasing nature's equilibrium between creation and annihilation. Numerous parasitic wasps focus on pest insects, and their presence maintains balance within entire ecosystems. They serve as both executioners and guardians, subtly influencing populations through their lethal dance. Within their delicate bodies resides a logic as ancient as the earth itself, an instinct that drives the continuation of life, even through the most haunting of means. Cicadas have the remarkable ability to slumber beneath the earth for over 10 years before finally making their appearance. In the depths of forests and fields, cicadas experience a lengthy and patient childhood. For 13 or sometimes 17 years, they linger in the shadows, patiently biding their time until the moment arrives to emerge. Suddenly, countless beings burst forth into the light, reshaping the scenery into a symphony of noise. Their synchronized appearance stands as one of nature's remarkable feats of timing, believed to be an evolutionary strategy designed to dazzle and confuse predators. After years spent hidden beneath the soil, their brief existence above ground unfolds in a matter of mere weeks. They sing, they mate, and they leave behind the next generation, setting the stage for the long cycle to commence once more. Each shell attached to a tree, each glimmering melody in the gentle breeze, contributes to a rhythm that has echoed for eons, serving as a testament that even the most fleeting existences can belong to something grand and timeless. A praying mantis possesses the remarkable ability to rotate its head a complete 180 degrees. Among insects, the praying mantis distinguishes itself with a remarkable and somewhat eerie intelligence. It stands out as one of the rare few that can swivel its head from side to side, occasionally almost looking behind itself. This ability to move bestows a broad awareness of its environment. The creature's large compound eyes possess the remarkable ability to detect motion at speeds far surpassing that of the human eye, complemented by 3 smaller eyes that assist in assessing light and distance. A mantis remains still for hours, its folded forelegs held in a position reminiscent of hands in prayer. Yet the moment the prey draws near, it strikes with astonishing accuracy. Observing one tilt its head in your direction evokes an eerie sensation, as if it possesses an awareness of your gaze. The mantis inhabits a realm of tranquility and precision, a hunter cloaked in patience, residing in a space that balances allure and peril, where the very essence of silence transforms into an ideal tactic for the chase. The monarch butterfly embarks on a remarkable journey, traversing thousands of miles, guided by an innate sense of direction. Each year, delicate monarch butterflies embark on a journey across a vast continent, following an innate map illuminated by sunlight and guided by the Earth's magnetic forces. Starting in the northern areas of the United States and Canada, they gracefully move southward, traversing mountains, rivers, and deserts to arrive at the mountainous forests of central Mexico. The journey stretches across vast distances, yet not a single butterfly manages to undertake the entire round trip. Several generations are required to perpetuate the migration cycle, with each one seemingly aware of the route, as if the memory had been passed down through time. Their wings, delicate as paper, possess a resilience that challenges the notion of fragility. It is believed by scientists that the position of the Sun and Earth's magnetic field are utilized for orientation, with adjustments made instinctively to maintain the correct course. Upon their arrival, millions gather in the cool, high forests, their orange and black wings transforming the trees into vibrant tapestries of resilience, beauty, and instinctive navigation. Certain beetles possess the remarkable ability to endure the experience of being consumed, emerging from the ordeal unscathed. In a remarkable display of resilience, certain beetles manage to withstand the unimaginable. When consumed by frogs or toads, they continue to live within the predator's stomach. Their resilient outer shells shield them from digestive acids, and their capacity to endure oxygen deprivation enables them to bide their time for an opportunity to escape. After enduring the struggle for hours, they emerge from the frog's mouth, or even its vent, appearing remarkably untroubled by the experience. This peculiar approach offers them an opportunity for renewal, where many beings would encounter only a conclusion. The phenomenon, as described by scientists, stands as a vivid illustration of evolutionary boldness. These beetles have transformed their predators into temporary sanctuaries instead of mere resting places. Their defiance stands as a subtle wonder, a testament to life's ability to adapt in ways that challenge logic, persevering through a blend of cleverness and resilience, concealed beneath a modest exterior of strength and resolve. Ant colonies engage in meticulously coordinated battles against their neighboring colonies. Though diminutive in size, ants exhibit societies that reflect the tactics of long-ago military forces. As rival colonies converge, they partake in battles characterized by remarkable organization. As scouts identify the enemy lines, chemical signals ripple through the ranks, and waves of soldiers come together in synchronized formations. Certain species ensnare their foes, compelling them to work, while others engage in fierce combat, until one faction is utterly vanquished. In the midst of these wars, individual ants display unwavering loyalty, sacrificing themselves without a moment's hesitation for the sake of their colony. The battles may endure for days, resulting in the loss of thousands of ants in their struggle for territory or resources. Even so, the aftermath unfolds, not in chaos, but in a sense of renewal. The survivors, in their resilience, gather their lost and embark on a new journey of rebuilding and renewal. Deep within the earth, a timeless cycle of struggle and collaboration has played out over countless millennia. Observing it intently reveals the fierce determination and the cohesive strength that characterize the most organized armies of the insect realm. A cockroach possesses the remarkable ability to survive for days, even after losing its head. Few creatures embody raw resilience quite like the cockroach does. The creature possesses a decentralized nervous system, enabling it to survive even when decapitated. Even in the absence of a head, it retains the ability to move, react to touch and carry on with its usual activities for several days or potentially weeks. This occurs as a cockroach utilizes small openings in its body, known as spiracles, for breathing rather than using its mouth. Ultimately, it meets its end not due to a wound, but from the relentless grip of thirst, unable to quench its need without a mouth. Cockroaches have endured for hundreds of millions of years, weathering every extinction event and adapting to nearly every environment on Earth. Their design remains remarkably efficient, with little alteration since the time of the dinosaurs. Often regarded as nuisances, they represent a remarkable aspect of evolution, serving as a testament to perseverance, demonstrating that survival is granted to those who endure, adapt, and persistently move forward. Stick insects possess the remarkable ability to regrow lost legs following the process of molting. The stick insect possesses a unique strength, one that is rooted not in swiftness or might, but in its remarkable ability to endure and regenerate. When a leg is lost to escape a predator, there is no mourning for the loss. Rather, it patiently anticipates the forthcoming molt. With each shedding of its outer skin, a new limb emerges, developing slowly until it reaches full functionality. This remarkable ability to regenerate is uncommon among insects, proving to be most effective during their youth, a time when growth occurs at a swift pace. As it undergoes healing, the stick insect remains utterly motionless, depending on its remarkable camouflage to blend seamlessly with the twigs and leaves surrounding it. Their survival hinges on silence, the art of remaining unseen, and the gradual, unwavering flow of time. Each new limb represents a subtle triumph, a testament to endurance, expressed through the cadence of shedding and rebirth. In quietude, it persists. In patience, it flourishes. Some flies possess the remarkable ability to traverse upside down on glass, utilizing their tiny claws and pads. Flies transform the unimaginable into the everyday. Their feet possess claws and pads, enabling them to adhere to smooth surfaces like glass or ceilings. Each pad is adorned with tiny hairs that release a delicate layer of liquid, resulting in adhesion at the molecular level. This enables the fly to traverse surfaces in an inverted position without losing its grip, secured by unseen physical forces. It possesses the ability to launch itself at a moment's notice in any direction, fine-tuning its hold and equilibrium with flawless accuracy. Researchers examining the mechanics behind this achievement have found inspiration for innovative adhesive materials and climbing robots. What seems like a simple annoyance at a window reveals itself as a remarkable feat of nature's design. The fly's effortless defiance of gravity illustrates how evolution often provides elegant solutions in their simplicity, enabling even the smallest creatures to achieve feats that appear to challenge the laws of the physical world. The Goliath beetle surpasses the weight of a mouse. Concealed within the lush rainforests of Africa lies one of the remarkable titans of the insect realm. The Goliath beetle, adorned with a lustrous shell and a robust physique, can surpass the weight of a small mouse. Some adults reach the size of a human hand, their armored forms adorned with captivating black and white designs. Even with their considerable size, they are still capable of soaring through the skies, their wings unfurled from beneath the weighty elytra, resembling sheets of vibrant, living metal. The larvae grow even larger, feasting on decaying wood until they attain the size of small rodents. These beetles, while harmless to humans, hold a monumental presence that cannot be overlooked. It serves as a reminder that in the vast tapestry of nature, size and scale hold a relative significance. Within their glossy shells lies a narrative of endurance, adaptation, and strength that stretches across millions of years. The Goliath beetle embodies the contradictions of nature, vast yet tender, timeless, continually revitalized by the fresh perspectives of each succeeding generation. The carbon dioxide we exhale draws in mosquitoes. Mosquitoes locate us not through vision, but rather through the aromas we emit and the air we exhale. With each exhale, a subtle trace of carbon dioxide escapes, detectable from several meters away. As they become aware of it, they pursue the unseen trail until they uncover its origin. The warmth, the scent of the body, and even the chemicals present on our skin serve to draw them nearer. Certain individuals draw the attention of mosquitoes more than others due to factors like genetics, blood chemistry, or metabolic rate. The tiny hunters, driven by an age-old instinct, have emerged as one of the most successful species on the planet. In an era long before the emergence of humans, mosquitoes sought sustenance from the blood of reptiles and robust mammals. Their capacity to navigate life through the very air around them renders them intriguing and powerful. In their delicate flight, there exists a captivating interplay of beauty and menace. Evidence emerges that even the tiniest beings possess the power to influence the trajectory of evolution. Moths find their way guided by the glow of the moon. For countless generations, moths have journeyed under the glow of the moon. They navigate their journey by maintaining a steady angle towards the moon, a dependable beacon in the night. This celestial compass enables them to traverse great expanses with an almost whisper-like grace. Yet, artificial lights bewilder their age-old navigation. Attracted by the radiance, they swirl ceaselessly around the lamps, confusing them for the distant light that had once led them through woods and meadows. Their delicate, dusty wings caress glass and flame, caught in the paradox of their flawless accuracy within a flawed reality. In the untouched wilderness, they continue to move with a quiet grace beneath the stars, tracing the same paths their ancestors once followed, when the night sky served as their sole guide. Their journey unfolds like a lyrical reflection of the ancient earth, a delicate ascent steered by intuition, illumination, and the unwavering cadence of time. Some caterpillars adopt the guise of snakes to intimidate birds. In the ongoing battle between predator and prey, certain caterpillars have developed an extraordinary form of camouflage. When faced with danger, they elevate the front of their bodies, showcasing patterns that resemble the eyes and scales of a snake. The illusion captivates with its startling realism, featuring swaying motions that evoke the image of a serpent poised to strike. This maneuver is a masterful display, an impeccable ruse that can send famished birds scattering in bewilderment. The metamorphosis from harmless larva to a menacing replica serves as a remarkable illustration of the principles of natural selection in action. Through the mastery of fear instead of fleeing, these caterpillars endure, ultimately transforming into butterflies or moths. In the quietude of a leaf, it is revealed that bravery can manifest in various ways, and that the essence of survival frequently hinges on ingenuity as much as on resilience. Honeybees possess the remarkable ability to recognize individual human faces. Amidst the bustling harmony of a hive, honeybees exhibit an unexpectedly intricate form of intelligence. Experiments have demonstrated that these subjects possess the ability to recognize and recall human faces, effectively distinguishing one individual from another, even after the passage of several days. They accomplish this by employing the same pattern recognition skills that enable them to recognize flowers. Though their brains are diminutive, akin to a pinhead, they possess an astonishing ability to process visual information with remarkable efficiency. This remarkable skill enables them to weave through bustling environments and find their way back to their hives from great distances with unwavering precision. Bees engage with thinking patterns, shapes, and contrasts, perceiving their surroundings as an intricate web of relationships rather than mere images. When a bee hovers near your face, it may not merely be responding to scent. It could be engaged in a careful observation. It serves as a soft reminder from nature that intelligence manifests in various ways, and even a being crafted from wax and sunlight can hold on to the visage of another. The bombardier beetle employs a remarkable defense mechanism, propelling boiling chemicals to protect itself. When faced with danger, the bombardier beetle transforms into a formidable weapon. Within its abdomen lie two chemical chambers that combine to create a powerful explosive reaction. In a flash, the beetle unleashes a stream of scalding liquid towards its assailant, achieving temperatures fierce enough to sear flesh. The explosion is managed by a delicate valve system that safeguards the beetle from self-harm, showcasing a remarkable feat of evolutionary design. With each burst comes a distinct pop, a manifestation of chemistry transformed into a protective measure. This adaptation has captivated both scientists and engineers, sparking research into miniature propulsion systems and controlled reactions. The beetle's defense embodies not aggression, but rather a graceful survival, executed with remarkable precision. It reveals that nature possesses the ability to create intricate mechanisms comparable to any machine, concealed within a being tiny enough to rest in the palm of a hand. Deep underground, ants cultivate fungus in their intricate farms. Deep within the shadowy earth of the forest, leafcutter ants meticulously cultivate gardens that could compete with the finest human farms. Fragments of leaves were cut, not for consumption, but to nourish the fungus that supports their colony. The leaves drift along in unending streams, creating verdant currents that vanish into the ground. In that place, worker ants diligently grind them into a fine pulp and meticulously inoculate them with fungal spores. The expanding fungus transforms into sustenance for the colony, while the ants tend to its well-being with remarkable diligence. Contaminants are removed, humidity is regulated, and even natural antibiotics produced by bacteria on their bodies are utilized. This partnership has endured for millions of years, a subtle alliance between two species that rely completely on one another. Deep underground, concealed from the sun's rays, a group engages in an ancient form of agriculture, nurturing life with meticulous care and unwavering dedication in the shadows. The jewel wasp possesses the ability to manipulate the mind of a cockroach. The jewel wasp's allure conceals a haunting expertise in the realm of biology. Upon encountering a cockroach, it administers two exact stings. The initial strike immobilizes the prey's forelimbs. The second, directed precisely at a region of the brain responsible for movement, strips away its capacity for independent action. The cockroach stays alive yet subdued, permitting the wasp to guide it like a companion into a burrow. There, an egg is laid upon its body, and the entrance is sealed. Upon hatching, the larva begins to consume the living host, ultimately emerging as a new wasp. This chilling cycle is both terrifying and remarkable in its accuracy. Each movement, each chemical signal, is meticulously calibrated to guarantee success. Within the jewel wasp's radiant form resides one of evolution's most peculiar creations, a narrative that illustrates how life can manipulate even awareness for the sake of survival. Butterflies retain the scents they encountered during their time as caterpillars. The metamorphosis of butterflies is complete, yet traces of memory endure. Research indicates that caterpillars conditioned to link specific scents with nourishment continue to react to those scents even after undergoing metamorphosis. In the chrysalis stage, their bodies undergo a transformation, dissolving and rebuilding, while remnants of neural memory linger on. This continuity links their larval and adult lives, weaving a tapestry of experience that traverses one of nature's most striking divides. It implies that memory possesses a strength that surpasses mere structure, embedded within the very reconfiguration of the nervous system. Envisioning a butterfly, remembering the subtle sweetness of a leaf it once consumed as a caterpillar, reveals the enduring nature of identity amidst transformation. It serves as a vibrant symbol of both continuity and change, illustrating that even amidst total renewal, remnants of our past inevitably emerge in our evolution. Fleas possess the remarkable ability to leap hundreds of times their own height. Despite their small size and lack of wings, fleas exhibit one of the most remarkable leaps found in the animal kingdom. Their legs accumulate energy through a unique protein known as racilline, functioning similarly to a spring. Upon release, the flea is propelled upward with remarkable force, soaring over 100 times its body height in a single leap. This skill allows it to traverse the fur of its host, deftly avoiding peril or seamlessly transitioning between creatures. The accuracy of this leap is unparalleled, enabling fleas to touch down precisely at their intended destination. What appears to be a mere annoyance is, in reality, a remarkable feat of engineering, crafted by the forces of evolution to transform muscle and elasticity into bursts of energy. Within the serene act of a solitary jump, there unfolds a lesson in physics, crafted by nature, illustrating that true greatness frequently resides in the most humble and overlooked aspects of existence. Male moths possess the remarkable ability to sense a female's fragrance from great distances. In the shadows of night, male moths find their way, guided by unseen signals that float through the air. Females emit pheromones, chemical fragrances that can traverse remarkable distances. Some males possess the remarkable ability to detect a single molecule amidst billions, their antennae finely attuned to the scent. The delicate sensors, adorned with fine hairs, capture even the faintest traces of fragrance. Upon catching the signal, the male pursues it with relentless determination, weaving his way toward the source with a clear and focused intent. This capability enables reproduction even over extensive terrains, driven solely by chemical signals. To the observer, the night appears tranquil, yet for moths, it teems with unseen pathways and hushed communications wafting through the air. In a realm where perception transcends the ordinary, the inhabitants navigate their existence through the delicate interplay of scent and instinct. This unique sensory dimension serves as a poignant reminder of the myriad ways in which life's communication unfolds, often eluding the grasp of our conventional senses. During floods, fire ants exhibit remarkable behavior by forming living rafts that allow them to float. As floodwaters ascend, fire ants neither succumb nor retreat. Instead, they hold on to each other tightly, intertwining their legs and mandibles to form living rafts. These floating structures endure for weeks, transporting the colony's queen and larvae securely over the water. Every ant maintains its buoyancy through the delicate balance of surface tension, and collectively, they create a dynamic, living island that adapts to the changing environment. The unity is so profound that the raft becomes one living entity, reacting together to waves, obstacles, and dangers. This survival strategy has enabled fire ants to thrive in some of the most extreme environments on Earth. It vividly illustrates the power of collaboration amid calamity, revealing how even the tiniest beings can accomplish the extraordinary through unity. In their living boats of courage and instinct, they reflect a profound strength rooted in trust and unity. The smallest of insects measures less than a grain of salt. At the very edge of what the eye can perceive resides the fairy fly, a wasp so diminutive that it floats like a speck of dust. Some species of adults measure less than 0.2 of a millimeter in length, making them smaller than a grain of salt. Their wings possess a delicate quality, adorned with fine hairs that enable them to glide gracefully through the air instead of flapping. Though small in size, these creatures are fully developed insects, possessing eyes, antennae, and the capability to fly and reproduce. Eggs are laid within the eggs of other insects, initiating a life cycle that unfolds on a microscopic scale. Envisioning a complete world in such a miniature form reveals the immense expanse of life itself. Even in the tiniest of spaces, evolution reveals its capacity for intricacy and elegance. The fairy fly embodies a gentle reminder of creation, a testament to the existence of wonder that transcends the boundaries of our vision. Ladybugs emit a noxious odor to ward off potential threats. Though ladybugs appear delicate, they are equipped with one of nature's most ingenious forms of protection. When faced with danger, they release a yellowish fluid from their leg joints, which is both odorous and distasteful to potential predators. This oily secretion, known as reflex bleeding, serves to transport toxins that may deter birds and various insects from attempting another bite. The The striking red and black pattern of a ladybug's wings acts as a cautionary signal, a vivid reminder that a lure may conceal peril. For predators, these colors serve as nature's unmistakable warning. Ladybugs dedicate a significant portion of their time to feasting on aphids, thereby protecting gardens and crops from potential devastation. Yet, as peril draws near, they transform into masters of endurance. Their allure conceals a subtle intensity and a bond refined over countless millennia of evolution. The next time one is spotted resting on a leaf, it becomes clear that beneath those gleaming spots resides a small warrior, cloaked in both beauty and protection. The wings of the atlas moth resemble the head of a snake. The atlas moth, among the largest insects on the planet, presents a flawless illusion upon its wings. The tips of its forewings take on the appearance of a snake's head, adorned with eye-like patterns and graceful, curving outlines. When faced with danger, the moth flutters its wings, causing the intricate pattern to spring to life, surprising the birds and lizards that might have otherwise attacked. The moth possesses a wingspan that can extend beyond 30 centimeters, yet it seldom ventures far from its resting place. In its adult form, it possesses no mouth and exists for merely a few days, relying solely on the energy accumulated during its caterpillar phase. Throughout its brief existence, it depends on cunning, elegance, and the subtle strength of illusion. In the stillness of a tropical night, broad wings unfurl like silk lanterns, glowing faintly in the moonlight. The atlas moth serves as a reminder that even the most fleeting moments of life can be experienced with a sense of magnificence and enigma. Dung beetles navigate through the night, using the Milky Way as their guide. Within the gentle shadows of the African plains, dung beetles engage in a remarkable display of celestial navigation. Upon receiving their prize, they dashed down the street in a line, eager to evade their rivals. It was revealed by scientists that their paths are not guided by the moon or familiar landmarks, but rather by the luminous presence of the Milky Way itself. Even when clouds shroud the stars, the subtle ribbon of cosmic illumination leads them onward. They ascend onto their rolling spheres, take a moment to pause and orient themselves before resuming their relentless journey through the dust. This remarkable ability allows them to stand out as the sole insects recognized for their use of the stars in finding their way. The narrative reveals a remarkable bond, highlighting the interplay between the tiniest beings and the boundless expanse of the cosmos. The beetle, laboring under its load amidst a vast expanse of starlight, emerges as a representation of resilience and universal balance, connecting the realms of Earth and the heavens. Certain termite queens have the remarkable ability to survive for many decades. Within the concealed layers of a termite mound resides a queen, destined to reign far beyond the lifespan of countless trees. Once fully mature, she swells with fertility, her abdomen expanding to the point where movement becomes impossible. Amidst a throng of attendants, she dedicates her days to the production of thousands of eggs, safeguarding the perpetual renewal of the colony. Among the longest-lived insects on Earth, some termite queens have been known to survive for over 20 years. Her body thrums with the cadence of creation, each pulse infusing fresh vitality into the colony. She is cared for, cleansed, and nourished by her workers, honored as the essence of their civilization. Outside her chambers, soldiers stand watch over the mound, ensuring the airflow remains steady and tending to the repairs of the walls. Within her, the destiny of countless lives unfolds. She exists as both ruler and automaton, a vibrant representation of continuity, tenacity, and the peculiar, lasting reasoning of existence beneath the surface. The Hercules beetle exhibits a changing color based on the level of humidity. The Hercules beetle, renowned for its remarkable strength, also showcases an equally astonishing characteristic. The shell possesses the remarkable ability to alter its color in response to the changing weather conditions. In arid conditions, it takes on an olive or yellow hue. Yet as moisture increases, it transforms into a rich, deep green or even black. The color shift arises from tiny structures within the beetle's shell, which change the way light is reflected based on the levels of moisture present. In the dense forests of Central and South America, where these giants dwell, it may assist with camouflage or temperature regulation. The males, distinguished by their long, curved horns, engage in dramatic battles for mates, their clashes resonating softly through the foliage. Underneath their resilience, there exists a beauty that is both practical and enigmatic. The Hercules beetle embodies transformation, its shifting colors mirroring the vibrant heartbeat of the rainforest, and the intricate harmony of strength, environment, and adaptation. Within the depths of their bodies, dragonfly larvae possess hidden gills that allow them to breathe. Before they transform into the elegant creatures that gracefully soar above ponds, dragonflies exist primarily beneath the surface, as larvae. At this stage, they utilize gills that are situated not externally, but internally within their rectum. Water flows in and out, enabling oxygen to traverse the concealed folds deep within their bodies. This mechanism can also serve for jet propulsion, releasing bursts of water that unexpectedly propel the larvae forward with remarkable speed. Within this hidden world of water, they emerge as formidable predators, consuming tadpoles, tiny fish, and various insects. For years, they exist unnoticed below the surface, anticipating the moment they will ascend a reed and undergo a transformation. As they emerge, they shed their old skin, unfurl their new wings, and ascend into the sky. The tale of the dragonfly unfolds with themes of concealed power, metamorphosis, and the serene endurance that comes before radiance. A solitary colony of army ants may encompass millions of members. In the heart of the tropical forests, army ants flow through the underbrush like a vibrant, living river. A solitary colony possesses the capacity to accommodate millions of individuals, each executing its designated role with flawless harmony. In vast columns, they traverse the forest floor, devouring all that lies before them. There exists no everlasting abode. Rather, they construct ephemeral shelters solely from their own forms, intertwining legs to establish barriers and spaces that accommodate the queen and her offspring. As night falls, the swarm envelops itself, transforming into a living fortress. As dawn breaks, it unfolds, moving ahead with an insatiable yearning. The colony functions as one entity, a unified consciousness propelled by instinct and togetherness. Observing their progression reveals a rhythm of existence that resonates with both timelessness and certainty, a manifestation of nature's unwavering determination to thrive, nourish, and persist. Some butterflies sip the tears of slumbering creatures. Within the humid jungles of South America, one might occasionally observe butterflies delicately resting upon the faces of slumbering turtles, caimans, or even birds. They do not consume flesh or blood. Instead, they feed on tears. The briny substance offers essential minerals that are lacking in their nutrition. With gentle tongues, they taste the dew without disturbing their hosts, crafting one of the most peculiar and intimate interactions in the natural world. Scientists refer to it as lacryphagy, the act of consuming tears. The relationship is both unsettling and gentle, emerging from a place of need rather than malice. Within the serene embrace of the rainforest, a gentle interaction between predator and participant unfolds, creating a moment of tranquil beauty. The butterfly's iridescent wings shimmer in the dim light, while it feeds on sorrow itself, reminding us that even nourishment can take the gentlest and most unexpected forms. Mosquitoes use heat vision to find bird vessels. A mosquito's world is mapped in warmth. As it approaches a host, its sensory organs perceive subtle variations in temperature across the skin. The warmth of blood coursing just under the skin serves as a guiding light, directing its proboscis with remarkable accuracy. Once it lands, the mosquito probes delicately until it finds the perfect spot to feed. This remarkable ability comes from specialized receptors in its antennae and mouthparts that respond to infrared radiation, allowing it to sense heat the way some snakes do. The entire process is a masterpiece of biological engineering, refined over millions of years. While we feel the sting as irritation, the mosquito experiences a world sculpted in gradients of warmth, scent, and breath. In its silent pursuit of blood, it follows the oldest rhythm of all life on Earth: the exchange of energy between bodies, invisible and eternal. The loudest insect on Earth can be heard from half a mile away. In the heat of summer, the air vibrates with the call of the cicada, one of the loudest sounds produced by any insect. Certain species can generate songs reaching over 100 decibels, powerful enough to carry across fields and forests. The sound is made by rapid contractions of special muscles that flex membranes on their abdomens, creating a resonant mechanical rhythm. Each species has its own distinct call, used to attract mates or mark territory. The chorus of thousands creates a soundscape that can feel almost hypnotic, a deep hum that seems to rise from the ground itself. For the cicadas, this thunderous music is both love song and survival strategy, overwhelming predators through sheer volume and numbers. Their brief, noisy lives are lived in the service of renewal, their voices joining in one vast, vibrating hymn to the summer sun. Walking sticks can reproduce without males. Some species of walking sticks have evolved a remarkable form of reproduction known as parthenogenesis. Females can produce offspring without mating, creating exact genetic copies of themselves. In times when males are scarce or conditions are harsh, this allows populations to endure and spread. Entire forests may be home to generations of identical females, continuing a lineage that never needed a partner. When males do appear, sexual reproduction resumes, introducing variation once again. This balance between cloning and diversity gives walking sticks incredible resilience. They are masters of invisibility, blending perfectly with twigs and leaves, yet their hidden lives carry profound lessons about survival. In their quiet way, they reveal how life always finds a method to continue, whether through union or solitude, keeping the ancient rhythm of reproduction alive in the simplest and most astonishing of forms. Some leafhoppers create musical vibrations we cannot hear. Though leafhoppers appear silent, they live in a world filled with hidden music. Instead of producing audible sounds, they send vibrations through plants, communicating by rhythm rather than tone. Using small organs on their abdomens, they generate tremors that travel along stems and leaves, carrying messages about territory, mating, or danger. These vibrations are too faint for human ears, but can be detected with special equipment. In dense vegetation, the air may seem still, yet the plants themselves hum with coded conversation. Leafhoppers rely on this private language to survive, avoiding predators who cannot hear their messages. It is a symphony of touch rather than sound, a reminder that life speaks in many voices beyond our perception. The next time the wind stirs the grass, imagine 1,000 tiny instruments playing within it, unseen, unheard, but endlessly expressive. The mayfly lives for only a few hours after becoming an adult. The mayfly's life is a study in impermanence. After spending months or even years underwater as a larva, feeding and growing, it emerges into the air as an adult with one purpose: to reproduce. It has no mouth, no stomach, and no need for food. Within hours, sometimes less than a single day, it mates, lays eggs, and dies. The air around rivers becomes filled with their fragile wings, fluttering in clouds of golden light. To human eyes, such brevity may seem tragic, but in nature's rhythm, it is perfect timing. Each generation ensures the next, continuing a cycle that has endured for more than 300 million years. The mayfly's fleeting existence reminds us that beauty and transience often walk hand in hand. In its short flight, it lives an entire lifetime, one that ends where it began, beside the quiet water. Certain beetles can withstand pressures that would crush steel. Among the desert sands of North America lives a creature of remarkable endurance, the diabolical ironclad beetle. Its exoskeleton is so tough that it can survive being run over by a car without injury. The secret lies in the intricate interlocking design of its shell, where layers of chitin are arranged like a jigsaw puzzle that distributes pressure evenly. This natural armor allows it to resist crushing forces that would destroy almost any other insect. Scientists studying its structure have drawn inspiration for developing stronger materials for aircraft and protective gear. Despite its fearsome name, the beetle feeds mostly on fungi and decaying plant matter, living a quiet life beneath bark and leaf litter. Its strength is not in aggression, but in design, a reminder that true resilience often lies in the unseen architecture of survival. Termites use sunlight and airflow to regulate their mound temperature. A termite mound may appear to be a simple pile of earth, yet it is a marvel of environmental engineering. Inside, the temperature and humidity remain constant year-round, regardless of the conditions outside. Termites achieve this by constructing an intricate network of tunnels and vents that direct airflow through the mound. As warm air rises, cooler air is drawn in from below, creating a self-regulating circulation system. Some species even build their mounds facing north and south to capture sunlight at just the right angles. This living architecture allows the colony's delicate fungus gardens to thrive. Engineers and architects have studied termite mounds to design buildings that cool themselves naturally without electricity. What seems like instinct is in fact a form of wisdom encoded in evolution, transforming simple creatures into silent masters of sustainable design. Butterflies see colors we cannot even imagine. To a butterfly, the world is painted in hues beyond human comprehension. Their compound eyes can perceive ultraviolet light, allowing them to see hidden patterns on flowers that guide them to nectar. What appears plain to us may glow with invisible markings to them. Different species see slightly different ranges of color, some perceiving the polarization of light itself. Their vision shapes how they navigate, how they recognize mates, and how they experience the landscape around them. The brilliance of their wings mirrors the richness of their perception, each shimmer a reflection of how they see. In the soft morning light, a butterfly flutters, not just through color, but through wavelengths that exist outside our senses. Their eyes remind us that beauty is not limited to what we perceive, and that reality is far more colorful than our vision can ever reveal. Mosquitoes are among the deadliest animals in human history. Despite their size, mosquitoes have shaped the fate of civilizations. By carrying diseases such as malaria, yellow fever, and dengue, they have been responsible for more human deaths than any other creature in recorded history. Ancient armies were weakened by them, explorers delayed, and empires altered by the spread of illness through their tiny bites. The female mosquito, needing blood to nourish her eggs, becomes an unwitting messenger of pathogens. Yet mosquitoes also play a role in ecosystems, serving as pollinators and food for countless species of fish, birds, and bats. Their story is one of balance and consequence, of how even the smallest life can tip the scales of history. In the hum of their wings lies both menace and meaning, a reminder that power is not measured in size, but in influence, written across time in the quiet persistence of flight. Some beetles can live inside volcanic ash fields. In places where life should not exist, certain beetles thrive. After volcanic eruptions, when ash still smolders and the landscape is bare, these pioneers arrive. They burrow into cooling soil, feeding on whatever organic matter remains. Their bodies are adapted to heat and dryness, with shells that reflect sunlight and conserve moisture. Over time, they help transform sterile ground into living soil, breaking down minerals and creating pathways for plants to take root again. In this way, they're among the first engineers of renewal after destruction. Their presence marks the beginning of recovery, the first pulse of life returning to a wounded world. These beetles carry within them the spirit of resilience, showing that even in the shadow of fire, nature finds a way to rebuild and begin again. The assassin bug hunts using camouflage and patience. The assassin bug lives by stealth, and precision. It hides among leaves or bark, its body shaped and colored to vanish into the background. When prey passes close, it strikes with a needle-like beak, injecting enzymes that liquefy the victim from within. It then drinks the fluid quietly, leaving only an empty shell. Some species go further, using the carcasses of their prey as camouflage, wearing them as armor against detection. Their methods are efficient, calculated, and unsettlingly intelligent. Despite their fearsome nature, assassin bugs play an important ecological role, controlling pest populations and maintaining balance in their habitats. Each ambush they carry out is an act of equilibrium, a necessary exchange within the food web. In their stillness and precision lies the artistry of the hunter, a reminder that nature's most elegant strategies are often its most silent. Cockroaches have been on Earth since before the dinosaurs. Long before dinosaurs walked the Earth, cockroaches were already thriving. Fossil evidence shows that their ancestors lived more than 300 million years ago, scurrying beneath the ferns of ancient forests. Through ice ages, meteor impacts, and the rise and fall of continents, they have endured. Their adaptability is unmatched. They can survive without food for weeks, withstand radiation levels fatal to humans, and squeeze through gaps thinner than a coin. Each time the world has changed, they have changed with it, outlasting countless other species. Though often reviled, the cockroach is a symbol of persistence and evolution's genius for endurance. In every dark corner and every forgotten space, they continue a lineage older than mammals, reptiles, and birds. They are survivors written into the very history of life, living fossils that whisper of the planet's most ancient and unbroken story. Male crickets serenade females by rubbing their wings together. In the quiet warmth of the night, the song of a cricket drifts through the grass. That gentle chirping is not a voice, but the sound of wings scraping together in rhythm. Male crickets produce their song by rubbing a sharp ridge on one wing against a file-like surface on the other, creating a vibration that carries through the air. Each species sings in its own pattern, with some chirps quick and steady, others slow and melodic. The sound serves as both invitation and competition, calling to potential mates while warning rivals to stay away. A female listens closely, drawn to the most precise rhythm, the truest sign of health and strength. To humans, the cricket's song brings calm and nostalgia, a heartbeat of summer evenings. Yet to the crickets themselves, it is a language of longing, connection, and the timeless music of survival. Some wasps turn spiders into web-building slaves. Among the many astonishing strategies in nature, few are as haunting as that of the parasitic wasp that enslaves spiders. The female wasp seeks out a host, stings it with pinpoint accuracy, and lays an egg upon its back. The spider continues to live, seemingly unharmed, but the growing larva releases chemicals that alter the spider's behavior. When the time comes, the spider abandons its normal web and builds a special reinforced structure unlike any it has spun before. This new web serves as a cradle for the wasp's cocoon. Once the structure is complete, the larva kills the spider and takes its place in the web it forced into being. It is a story of eerie precision, of instinct and control, interwoven in biology's darker poetry. Within this grim choreography lies the reminder that evolution creates both beauty and cruelty, often in the same delicate form. Fireflies synchronize their flashes across entire forests. In certain tropical nights, entire forests seem to breathe with light. Thousands of fireflies gather in the trees, their flashes pulsing together in perfect harmony. Scientists believe this synchronization is a form of communication, allowing males and females to find each other amid the darkness. Each tiny lantern glows through a reaction between oxygen and luciferin inside its abdomen, producing light without heat. When the rhythm spreads across the trees, it becomes a living constellation, a terrestrial mirror of the sky. In some regions, these gatherings have been celebrated for centuries as natural wonders. The precision of the timing remains partly mysterious. A collective awareness that seems almost telepathic. For a few precious moments, the forest becomes a single glowing organism, breathing in unity. The synchronized light of fireflies is nature's quiet symphony, proof that connection and beauty can arise from the simplest sparks of life. The orchid mantis mimics flowers to lure its prey. The orchid mantis is a living illusion of color and grace. Its pale pink and white body perfectly imitates the petals of tropical blossoms. Resting among real orchids, it becomes indistinguishable from them, waiting for unsuspecting insects to draw near. Butterflies and bees, attracted by what appears to be nectar, instead become part of the mantis's silent feast. Even the way it moves mimics the gentle swaying of a flower in the wind. Its disguise is so convincing that researchers once mistook it for a plant adaptation, rather than an animal's. This masterpiece of camouflage shows how deeply evolution can sculpt, form, and behavior together. The orchid mantis does not chase its prey. It waits, still and radiant, until life comes to it. In its quiet deception lies a beauty that is both serene and ruthless, an art of survival painted in living color. Certain ants explode to protect their colony. In the rainforests of Southeast Asia, some ants possess a defense unlike any other. When frightened, they rupture their own bodies, releasing a sticky, toxic fluid that immobilizes intruders. The act is fatal to the ant, yet it saves the colony. These self-destructive soldiers are the ultimate defenders, their sacrifice woven into the fabric of their society. Each explosion releases chemicals so strong they can repel much larger predators. Scientists call this adaptation autothesis, a word that means self-sacrifice. It is a striking example of how far nature's designs can go in service of community. Within the colony, every individual is part of something larger, and the survival of the group outweighs that of the self. Their story is both tragic and awe-inspiring, a testament to the depth of cooperation and devotion that can exist in even the smallest forms of life. Butterflies can hear with their wings. While butterflies are known for color and grace, they also possess an unexpected sense of hearing. Hidden within the thin membranes of their wings are specialized structures that detect sound vibrations. These organs, called tympanal membranes, allow butterflies to sense the approach of predators, such as birds or bats. The vibrations travel through the delicate tissue like ripples across water, giving the butterfly a form of early warning. Some species respond by altering their flight pattern, darting unpredictably through the air. Others rely on this sense to stay still when danger passes nearby. The discovery of wing-based hearing has changed how scientists understand these insects, revealing that their wings are not only for beauty and movement, but also for awareness. Every flutter is part of a larger sensory world, where sound, color, and motion merge in perfect harmony beneath the open sky. A beetle, called the diabolical ironclad, can survive being run over by a car. In the deserts of California lives a beetle so tough that it can withstand the weight of a passing car. Known as the diabolical ironclad beetle, its exoskeleton is built like natural armor, composed of interlocking layers that distribute force across its body. This intricate design prevents cracks from spreading and allows the beetle to survive crushing pressures that would destroy nearly any other creature. Scientists studying its structure have found inspiration for new engineering materials, from aircraft shells to protective gear. Despite its formidable defense, the beetle lives a peaceful life, feeding on fungi and decaying wood. Its power lies not in aggression, but in endurance. Within its small, unassuming body exists a design perfected by evolution, a masterpiece of natural architecture, proving that resilience can be as elegant as it is strong. Insects were the first animals ever to take flight. Long before birds, bats, or humans lifted from the ground, insects claimed the air. Around 400 million years ago, they developed wings, unlocking a new dimension of existence. The first flyers were small, clumsy, and primitive, Yet their discovery of flight transformed life on Earth. Being able to rise above the surface allowed them to escape predators, find new habitats, and spread across continents. This innovation reshaped entire ecosystems, influencing the evolution of plants and animals alike. Fossils of ancient dragonflies show wingspans wider than a human hand, remnants of an age when the skies belonged entirely to insects. Every creature that soars today traces its heritage back to those tiny pioneers. Flight turned survival into art, transforming crawling creatures into explorers of wind and light. The story of insect flight is the beginning of movement itself, written in the language of wings. Some grasshoppers sing by striking their legs against their wings. The gentle trill of a grasshopper on a warm afternoon is a sound older than civilization. These songs are created not by voice, but by friction. The grasshopper rubs a roughened ridge on its hind legs against the edge of its wings, producing rhythmic vibrations. Each species has its own pattern, a code that identifies individuals and attracts mates. Temperature affects the pace of the song, so much so that counting chirps can estimate the warmth of the air. The sound fills fields and meadows like a living pulse of summer. To other grasshoppers, this is communication, not music to us. It becomes the soundtrack of peaceful days. Beneath the simple rhythm lies a physics lesson in sound production, an ancient melody carried on air through legs, wings, and sunlight. The grasshopper's song is a conversation between creature and world, woven softly through the heat of the day. Bees can solve simple math problems. Beneath their golden hum, bees hide a spark of intelligence that continues to surprise science. Studies have shown that honeybees can understand basic mathematical concepts, such as addition and subtraction. Using color-coded symbols during experiments, bees learn to associate certain patterns with increasing or decreasing quantities of shapes. They could then apply that logic to new problems, choosing the correct solution to earn a reward of sugar water. This ability suggests that their tiny brains process numbers in a way once thought limited to larger animals. Beyond counting, bees can recognize symmetry, learn from observation, and remember the location of flowers miles apart. Within the dark chambers of a hive, they dance to share geometry and distance, turning numbers into motion. The honeybee reminds us that intelligence does not require size, only structure, curiosity, and the quiet persistence of learning. Aphids give birth to live young without mating. Aphids, the small, sap-feeding insects, often found on garden plants, possess one of nature's most efficient reproductive systems. Many species can give birth to live young without mating, a process known as parthenogenesis. Within their bodies, developing embryos are clones of the mother, ready to begin feeding the moment they are born. In warm seasons, populations can multiply with astonishing speed, covering entire plants in days. Some aphids are even born pregnant, already carrying the next generation before they take their first sip of sap. As circumstances shift, males emerge, and the process of sexual reproduction begins anew, rejuvenating genetic diversity. This adaptable cycle guarantees endurance in times of plenty and in times of struggle. Aphids, though delicate, showcase a remarkable ingenuity through their straightforward approach. By mastering self-replication and timing, they transform vulnerability into success, quietly flourishing in fields and gardens as one of the planet's most resilient and adaptable life forms. Mosquitoes exhibit a preference for specific individuals compared to others. Those who have spent a summer evening outdoors are well aware that mosquitoes have their preferences when it comes to humans. Certain individuals draw in significantly more bites than their counterparts, and research has revealed the reasons behind this phenomenon. Mosquitoes are attracted to a combination of carbon dioxide, body heat, and certain chemicals present in human sweat and skin oils. Genetic factors play a role in these scents, indicating that body chemistry shapes how attractive a person is to a mosquito. Individuals with elevated metabolic rates or specific blood types release greater amounts of carbon dioxide, rendering them more susceptible to being targeted. Even the color of clothing can influence perception. As darker fabrics tend to attract more attention, the tiny hunters navigate through invisible trails of scent, heat, and breath. Their instincts honed over millions of years, guiding them with precision. Their choices might appear arbitrary, yet in the subtle dialect of chemistry, every individual stands as a distinct light amidst the shadows. Some moths consume blood, resembling tiny vampires in their feeding habits. While the majority of moths indulge in nectar, there exist a handful of species that have developed a more sinister appetite. The nocturnal visitors penetrate the skin of mammals, including humans, to consume small quantities of blood. Their specialized mouthparts, known as proboscises, possess the strength to pierce flesh while leaving no trace of discomfort. It is believed by scientists that this adaptation started as a method to extract minerals from the tears or fluids of animals, eventually evolving into blood feeding. In contrast to mosquitoes, these moths are harmless in terms of disease transmission. However, their behavior introduces a darkly enchanting element to their otherwise gentle image. In the stillness of night, their wings flutter softly as they draw sustenance from living hosts, completing a cycle that is both eerie and captivating. The image of a blood-drinking moth serves as a reminder that even the most fragile beings harbor mysteries, forged by necessity, instinct, and the boundless creativity of evolution. The bullet ant possesses a sting that is renowned for its excruciating pain, making it one of the most formidable in the world. In the lush rainforests of Central and South America, the bullet ant resides, a creature both feared and revered for the potency of its sting. The agony it inflicts has been likened to that of a gunshot, fierce and searing, enduring for hours on end. The venom is laced with neurotoxins that overwhelm pain receptors, producing an unforgettable sensation for nearly all living beings. In ancient times, indigenous tribes incorporated bullet ants into their initiation rituals, crafting gloves that young warriors donned to demonstrate their endurance and bravery. Even with their formidable defense, bullet ants remain non-aggressive unless they are provoked. In organized colonies, they diligently tend to larvae and gather food with a quiet determination. Their sting serves not as a display of malice, but rather as a profound testament to resilience. The bullet ant represents the intricate balance of nature, showcasing how beauty and peril can intertwine, and how even the tiniest of beings can evoke both admiration and reverence. The tsetse fly brings forth fully developed larvae. In a remarkable departure from the norm of the insect world, the tsetse fly brings forth its offspring in a live birth, setting it apart from the majority that lay eggs. Within the confines of the mother's body, a solitary larva develops, sustained by a unique milk-like fluid secreted by her glands. When the time comes, the larva emerges and promptly digs into the earth to begin its pupation process. This distinctive method of reproduction, known as adenotrophic viviparity, is uncommon among insects and strikingly resembles mammalian birth. The tsetse fly dedicates significant resources to each of her offspring, bringing forth only a limited number throughout her life, yet guaranteeing that each one has a robust opportunity for survival. Primarily located in sub-Saharan Africa, tsetse flies contribute intricately to ecosystems, yet they are notorious for transmitting sleeping sickness to both humans and animals. Their reproductive strategy unveils an unexpected gentleness, showcasing a small miracle of nurturing and attention in a being frequently regarded merely as a nuisance. The song of a cicada arises from the swift vibrations of its abdomen. As the summer air vibrates with melody, it frequently carries the distinct call of the cicada. The males create their unique calls through drum-like structures known as tymbals, which are situated on their abdomens. Muscles, strong and dynamic, contract and release these membranes with remarkable frequency, enhancing the sound as it resonates through the hollow chambers within the body. Every species produces its unique melody, weaving together a rich tapestry of sound that resonates throughout the vastness of the forests. The sound can reach levels surpassing 100 decibels, outshining the noise of numerous rock concerts. These melodies serve as invitations, crafted to draw in the elusive females concealed among the foliage. For us, they embody the essence of warmth and brightness, serving as a reminder of the rhythmic changes of the earth throughout the seasons. In each vibration resides a narrative of yearning and determination, of beings who have bided their time for years beneath the surface, only to emerge briefly and fill the atmosphere with melody before retreating once more into quietude. Some beetles possess the remarkable ability to breathe underwater by utilizing air bubbles as makeshift scuba tanks. Some beetles thrive just as well beneath the water's surface as they do on solid ground, all due to a remarkable adaptation. As they dive, a bubble of air becomes ensnared beneath their wing covers or among the delicate hairs on their bodies. This bubble serves as a small-scale scuba tank, providing oxygen and expelling carbon dioxide into the surrounding water. The process establishes a gradual exchange that can support the beetle for extended durations, even lasting hours. Scientists refer to it as a physical gill, a straightforward yet efficient method for underwater respiration. These beetles glide gracefully through ponds and streams, engaging in a delicate dance of feeding on small aquatic creatures and detritus. The shimmering air bubbles glint like tiny mirrors, reflecting sunlight through the water. It serves as a reminder that even the tiniest forms of life have perfected the craft of innovation, seamlessly adjusting to environments where the act of breathing transforms into a matter of exquisite artistry. Ants navigate their world by laying down chemical trails, creating unseen pathways for their journeys. To the observer, the journey of an ant might appear chaotic, but it is guided by a meticulously charted realm of fragrance. As ants traverse their environment, they create unseen pathways marked by chemical trails composed of pheromones. Other ants sense these trails with their antennae, tracing them to sources of food or returning to the nest. As more ants traverse the same path, the scent intensifies, solidifying the trail they follow. When the path disappears or is interrupted, fresh avenues emerge swiftly, showcasing extraordinary communal wisdom. This system enables colonies to synchronize intricate foraging behaviors autonomously, driven solely by chemical signals and instinctual responses. For an ant, the universe unfolds through a tapestry of scents rather than visuals, revealing a dynamic web of unseen pathways. Their coordination illustrates the profound ways in which communication can thrive in utter silence, intertwining countless lives through a language that dissipates like a whisper in the breeze. The weta of New Zealand has the ability to freeze completely and then return to life once more. In the frigid mountains of New Zealand, the weta survives in conditions that would prove fatal for most insects. In the depths of winter, it permits its body to succumb entirely to the freeze. Ice forms between the cells, yet remains absent within them, due to the presence of special proteins that safeguard against internal damage. As the temperatures climb, the wetness melts away, and life begins anew, as though the past had never occurred. This remarkable survival mechanism stands as one of nature's true miracles of endurance. The giant weta, one of the heaviest insects on Earth, leads a slow and ancient existence, foraging for leaves beneath the moonlight. The capacity to endure freezing showcases the boundless ingenuity of nature when confronted with adversity. In its stillness, preserved by ice, the weta emerges as a testament to patience and resilience. As spring arrives, its gentle movement re-emerges, a testament that even amidst the depths of winter, life patiently anticipates the return of warmth. Some butterflies are capable of traversing oceans carried by the wind. Certain butterflies embark on migrations that appear astonishing for beings so fragile. Species such as the painted lady and the monarch have been seen traversing oceans, propelled by winds that stretch across continents. The journeys unfold over thousands of miles, as successive generations carry on the voyage long after the initial travelers have departed. Researchers have observed butterflies journeying from Africa to Europe and even traversing sections of the Atlantic. Their delicate wings, appearing almost fragile, are ingeniously crafted to harness currents and soar with remarkable efficiency. As they journey, they nourish, reproduce, and take moments to rest, all while being directed by the unseen structure of the atmosphere. Every migration unfolds as a journey intertwined with a legacy, linking distant realms through gentle perseverance. In every flutter over open water, these butterflies embody a vibrant courage, expressed through their colors and graceful movements. As they drift between worlds, relying solely on instinct, sunlight, and the guiding winds, termites have the potential to generate a greater amount of biomass than the total produced by humanity as a whole. Concealed beneath the Earth's surface lies a vast population, its collective weight potentially surpassing that of all humanity combined. In the vast expanses of forests, savannas, and deserts, countless billions of termites thrive, their small size belied by their immense numbers. United, they create an expansive web of existence that perpetually regenerates the earth beneath them. Through the decomposition of wood, leaves, and various organic materials, nutrients are released, fostering the health of entire ecosystems. Every colony functions as a vibrant mechanism of rejuvenation, transforming the deceased into the living. In tropical regions, mounds can tower above individuals, with the population of workers within a single mound, potentially numbering in the millions. Their combined efforts mold the environment, impact the carbon cycle, and foster plant development across the globe. Though hidden from view, the realm beneath us vibrates with ceaseless activity, a silent society of creators that surpasses our own in both number and mass. Bees possess the ability to identify patterns and symmetry. The honeybee, celebrated for its organization and teamwork, also embodies a delicate appreciation for beauty. In a remarkable finding, researchers have unveiled that bees possess the ability to recognize and retain symmetrical patterns, showing a clear preference for balanced shapes rather than chaotic forms. This skill is employed to identify flowers with greater efficiency, leading them to those that provide the most abundant nectar. In controlled studies, it has been observed that bees possess the ability to differentiate between shapes, colors, and even artistic patterns. Their capacity to perceive symmetry could explain why the evolution of flowers tends to favor balance and proportion, as pollinators are naturally drawn to it. Within the hive, this same sensitivity shapes the geometry of the honeycomb, with each hexagon serving as a flawless embodiment of natural mathematics. The realm of the bee encompasses not just fragrance and melody, but also structure and balance. Their tiny eyes perceive order where we see simplicity, unveiling that even within the smallest minds, beauty and function are intricately connected. Some flies deposit their eggs within snails, which later hatch and emerge through the shell. In the peculiar realm of evolution, certain flies have transformed snails into vibrant nurseries of life. Female marsh flies meticulously search for particular snail species, carefully laying their eggs within the soft body through the shell's opening. The larvae emerge within, gradually feeding from the inside, ensuring the snail remains alive just long enough to provide a protective haven. As the larvae prepare to pupate, they emerge from their shell, crawling out and leaving behind the empty husk of their host. This haunting process reveals itself quietly in the shadowy recesses of ponds and marshes. It serves as a poignant reminder of the complexity and disquieting nature of survival strategies in the wild. Every life commences at the conclusion of another. A delicate interplay of creation and destruction unfolds over millions of years within the serene depths of the wetlands. The praying mantis possesses the remarkable ability to perceive its surroundings in 3 dimensions. Among insects, the praying mantis uniquely perceives the world in true depth. Similar to humans, it employs stereoscopic vision, merging images from both eyes to assess distance. This extraordinary adaptation enables the mantis to capture its prey with impeccable precision, timing its strike to the smallest fraction of a second. The triangular head possesses the ability to swivel almost completely, providing a wide-ranging perspective of its environment. Researchers examining the vision of mantises have employed miniature glasses to evaluate their depth perception, establishing that these creatures have a form of 3D sight that is unparalleled among other invertebrates. This remarkable skill transforms the mantis into a hunter of exceptional accuracy, capable of capturing a fly in flight with seamless elegance. As it tilts its head toward you, it is not merely curiosity that drives it, but a thoughtful assessment from a being that genuinely perceives the gaps between realms. Some beetles mimic ants with such precision that they seamlessly blend into their midst, remaining unnoticed. Within the hidden layers of the insect realm, the art of disguise holds the key to survival. Some beetles have adapted to resemble ants in appearance, scent, and behavior, enabling them to remain unnoticed within the confines of ant colonies. Their bodies have become slender, their antennae now curved, and their movements executed with flawless imitation. The colony's scent is mimicked through the production of chemicals that are identical to those utilized by the ants for recognition among themselves. In this manner, they roam unencumbered among their hosts, pilfering food, indulging in larvae, or merely relishing the security of the nest. The deception is so perfect that the ants embrace them as family, tending to and safeguarding them as if they were one of their own. It serves as a vivid illustration of the profound ways in which adaptation can shape one's identity. The beetle's borrowed life unfolds as a masterful dance of survival, taking place in the concealed shadows of the earth, under a realm governed by fragrance and quietude. The giraffe weevil possesses a neck that exceeds the length of its entire body. Deep within the rainforests of Madagascar resides one of nature's most peculiar artisans, the giraffe weevil. The male possesses a neck that can extend to 3 times the length of his body, a remarkable feature utilized for both construction and combat. As the weevil sets about constructing a nest, he meticulously rolls a leaf into a tube, skillfully using his elongated neck to shape it just right. Within this cradle, a single egg is laid by the female, and as the leaf descends to the forest floor, the larva emerges, concealed and secure. The males engage in duels, their long necks intertwining as they partake in a slow, calculated battle for the privilege to mate. In spite of their peculiar shapes, giraffe weevils glide through their environment with a serene elegance, their shiny black exoskeletons reflecting the verdant hues of the treetops. They exist as living sculptures, evidence that evolution crafts not just out of necessity, but also for the pure beauty of adaptation. Fireflies convey messages through their distinctive light patterns. To human eyes, the glow of fireflies appears to be a whimsical dance of light, yet for the insects, it serves as a means of communication. Every species employs a unique rhythm and pattern of light flashes to draw in mates and identify each other. Some species communicate through simple signals, while others engage in complex sequences, reminiscent of Morse code expressed in light. On a tranquil summer night, messages dance through the meadows and forests, creating a tapestry of visible exchanges filled with attraction and response. The light emanates from a chemical reaction occurring within the firefly's body, regulated with remarkable accuracy. In certain species, the females imitate the patterns of different types of fireflies to attract males, transforming communication into a form of deception. Each moment is imbued with significance, ranging from affection to peril, from romance to cleverness. Their luminous conversation transforms shadows into verse, demonstrating that even the tiniest existences convey themselves through intricate designs of illumination. Certain butterflies derive nourishment from decaying fruit and the fluids of animals. While butterflies are often seen as emblems of purity and vibrancy, the intricacies of their diets can be quite unexpected. Numerous species derive their sustenance not from nectar, but from the minerals present in decaying fruit, animal waste, or even the bodily fluids of decomposing organisms. These sources offer essential salts and nutrients, crucial for reproduction and flight. Along the lush riverbanks of the tropics, one can observe clusters of butterflies congregating around moist earth or decaying matter, gracefully sipping with their curled tongues. Scientists refer to this behavior as mud puddling. For the butterfly, decay holds a certain significance, serving as a reminder that beauty is often intertwined with the hidden rhythms of life and death. Their delicate forms, hovering above the Earth's fading matter, unveil a profound truth about the natural world. All things are interconnected. Renewal often emerges from the ashes of endings, and grace can blossom from the most unexpected and harsh circumstances. The Japanese hornet possesses venom potent enough to dissolve flesh. Among the largest hornets in the world, the Japanese giant hornet evokes a blend of dread and intrigue. The sting delivers a powerful venom filled with enzymes that break down tissue, resulting in excruciating pain and swelling. The aroma of the venom serves as a signal, leading other hornets to converge upon the same prey. Though it is often viewed with trepidation, this species holds significant ecological importance by controlling agricultural pest populations. In their pursuit, they navigate with a coordinated grace, assaulting honeybee colonies and transporting the remnants to nourish their young. Those who come across them frequently find themselves amazed by their immense size, as their wings produce a resonant mechanical hum. Though lethal when protecting themselves, they operate within the same equilibrium that rules all hunters, claiming lives solely to nourish their existence. Within their power resides a duality of destruction and purpose, serving as a reminder that every force in nature holds a significant role in the grand design. Termite soldiers employ their heads as vibrant, living door plaques. Within the confines of a termite mound, soldiers vigilantly stand watch over the narrow tunnels that connect to the outside world. Certain species have developed heads that are ideally shaped to fit these passages, enabling them to obstruct intruders by firmly wedging themselves in position. Their heads frequently take on a hardened, flat shape, serving as living shields that protect the colony from threats like ants or centipedes. When one soldier is dislodged, another promptly steps in to uphold the barrier. This defense system demands neither arms nor ammunition, but rather a steadfast commitment and selflessness. Every soldier lives solely for this purpose, dedicating their existence as a barrier to safeguard the entire colony. It presents a vision of harmony and commitment, a whole community operating as a single entity. Within the shadows of their tunnels, the stillness of their vigil transforms into the pulse of the colony's security and resilience. Certain beetles exclusively consume fungal spores that thrive on decaying wood. Within the hushed deterioration of decaying trees, minute beetles exist in a state of flawless adaptation. Some species rely solely on the fungal spores that emerge from decaying wood. The spores, abundant in nutrients, emerge only under the perfect conditions of moisture and shade, making their presence a transient marvel. The beetles navigate the complex labyrinth of decay, diligently collecting the unseen spores of fungi as they go about their daily tasks. Their presence guarantees an even distribution of nutrients across the forest floor, fostering the growth of new life from the remnants of what once was. This intricate interplay among the beetle, fungus, and wood uncovers the subtle intricacies of decay. What seems to be devastation is, in reality, a metamorphosis. Within each decomposing log lies a realm of microscopic collaboration, where beetles act as guardians of the forest's timeless cycle of renewal. The Hercules moth boasts wings that surpass the width of a human hand. The Hercules moth, residing in the lush rainforests of northern Australia and New Guinea, ranks among the largest moths on the planet. The wings can stretch over 30 centimeters, wider than a human hand, adorned with translucent eye spots that glimmer like moonlight. Though it boasts a grand size, the moth's existence as an adult is fleeting, lasting merely a few days. Devoid of a mouth and incapable of consuming food, It depends on the energy accumulated during its caterpillar phase. In that fleeting existence, it glides quietly through the balmy night, led by an innate sense and the gentle allure of the stars above. The caterpillar it once was remains remarkable, adorned with soft green spines and able to stretch to the length of a child's forearm. The life of the Hercules moth, brief yet profound, unfolds as a remarkable tale of transformation. The expansive wings serve as a brief reminder of the beauty and transience that characterize the realm of life. Ants have the remarkable ability to cultivate aphids, treating them much like miniature livestock. Within the small expanses of nature, ants have mastered the craft of farming. Certain species exhibit a remarkable behavior, caring for aphids by shielding them from predators and nurturing them, much like farmers do with their livestock. In exchange, the aphids generate a sugary substance known as honeydew, which the ants eagerly partake in. The ants delicately brushed the aphids with their antennae, encouraging the flow as they gathered it meticulously, drop by drop. Their herds are moved to fresh feeding grounds, and during rain, they are sheltered in their nests. This relationship stands as a remarkable illustration of collaboration across different species. It illustrates that the origins of farming predate humanity, tracing back millions of years to beings that gauge their territories in blades of grass. In their care and discipline, one can see a mirror of our inherent desire for connection, nurturing, and the collective effort required to sustain life. Cockroaches have the ability to learn by experiencing things repeatedly. Despite being frequently undervalued, cockroaches reveal an unexpected ability to learn. Experiments have demonstrated that they can learn to connect specific scents with food rewards, becoming increasingly responsive over time through repeated exposure. This type of associative learning resembles the way mammals develop habits. Despite possessing simple nervous systems, cockroaches demonstrate a remarkable ability to adapt swiftly to their changing surroundings, recalling safe hiding spots and reliable food sources. Their resilience stems from a combination of strength and a flexible mindset. In laboratories, it has been demonstrated that long-term memory allows for the recall of learned responses even after several days. These discoveries invite us to reconsider our beliefs regarding intelligence and awareness within the realm of insects. The cockroach, a creature that has endured for hundreds of millions of years, thrives not merely through sheer endurance, but through keen observation and adaptation traits that reflect the subtle intelligence present throughout all of existence. Certain insects generate antifreeze proteins, enabling them to endure the harsh conditions of Arctic winters. In the frozen silence of the Arctic, where temperatures plunge far below zero, certain insects persist through remarkable chemistry. Special proteins are produced by them, serving to prevent ice crystals from forming within their bodies. These antifreeze proteins attach to minuscule ice particles, preventing their expansion and preserving the integrity of the insect cells. This adaptation enables species such as the Arctic woolly bear caterpillar to endure numerous winters, freezing completely each year and thawing in the spring to resume their growth. The journey unfolds as a remarkable victory of biology, triumphing over the constraints of physics, showcasing a fragile equilibrium that safeguards life in the face of insurmountable challenges. These tiny creatures remain still beneath the snow and ice, their metabolism reduced to a near standstill. Yet, when warmth returns, they awaken as if from slumber, continuing the perpetual cycle of existence. In their frozen patience, a lesson in endurance emerges, illustrating that life persists even in the quiet heart of winter. The glow of fireflies is a dance of timing and rhythm, orchestrated by their own control. The glow of a firefly serves as a remarkable form of communication in nature, and it is far from random. Fireflies possess the remarkable ability to regulate the timing and rhythm of their flashes by delivering precise bursts of oxygen, which trigger a chemical reaction within their light-producing cells. Every species possesses a unique rhythm, and individuals have the ability to modify their timing to align with those around them. This coordination transforms solitary sparks into vast expanses of illumination that throb in unison. The mechanism operates with such remarkable efficiency that it generates no heat whatsoever, transforming almost all energy directly into light. In these vibrant lanterns, the realms of science and wonder intertwine seamlessly. Their glow transcends mere beauty, becoming a silent dialogue expressed through timing and pattern. Under the warm embrace of the summer sky, their rhythm transforms into a soothing lullaby of connection, quietly demonstrating the profound ways in which light can convey meaning. The dragonfly's eyes are composed of tens of thousands of lenses. The vision of a dragonfly approaches the realm of the extraordinary. Each of its two enormous eyes consists of as many as 30,000 individual lenses, each one capturing a piece of the world around it. Collectively, they form a sweeping vista that encompasses almost every angle simultaneously. Dragonflies possess the extraordinary ability to detect movement from impressive distances and can perceive colors that remain unseen by the human eye, such as ultraviolet light. Their remarkable skill in tracking several moving objects simultaneously sets them apart as extraordinary hunters, capable of capturing prey mid-air with unwavering precision. For the dragonfly, the sky unfolds as a vibrant canvas of movement and hue, rich with intricacies beyond our comprehension. The eyes serve not merely as organs of sight, they function as instruments of awareness, harmoniously attuned to the vibrant dance of life in motion. Each glimmer of light, dancing across its multifaceted gaze, embodies the brilliance of nature's artistry in precision and perception. Certain butterflies shimmer with colors that transcend the realm of pigments. The vibrant blues and greens of certain butterflies emerge not from pigments, but from their intricate structure. The tiny microscopic scales on their wings are arranged in layers that reflect and scatter light in precise ways, creating colors that shift with every angle. This phenomenon, referred to as structural coloration, indicates that the color is present solely in the light rather than in any material substance. The morpho butterfly of the Amazon is renowned for its remarkable effect, with wings that shimmer in an iridescence so vivid it can be spotted from hundreds of meters away. The shimmering surface captivates the eye while simultaneously confusing predators, flashing from vivid blue to dull brown as it glides through the water. These wings serve as nature's prisms, transforming light into a form of art. In their brilliance, there exists a reminder that color, akin to beauty, is frequently an illusion molded by light and perspective. Mosquitoes possess the remarkable ability to detect human sweat from afar. Long before they are seen or heard, mosquitoes possess the ability to detect humans through the slightest hint of scent. Their antennae and mouthparts are adorned with sensory receptors, enabling them to sense the chemicals present in human sweat, especially lactic acid and ammonia. The cues, along with the carbon dioxide exhaled, form a trail that mosquitoes can detect from several meters away. Once they were close, heat sensors were employed to identify areas of exposed skin. Their remarkable sense of smell has established them as some of the most effective hunters on the planet, capable of detecting blood even in the depths of darkness. Researchers examining these processes aspire to create more effective repellents by interfering with the chemical signals that draw them in. For the mosquito, every breath and heartbeat transforms into a guiding light in the darkness, leading it through the air toward its next meal. The pursuit unfolds with a grace that is both refined and unyielding, a ballet of fragrance and existence. Dung beetles possess the remarkable ability to roll balls that weigh up to 50 times more than themselves. Across fields and deserts worldwide, dung beetles engage in remarkable displays of strength that seem almost beyond belief. A solitary beetle possesses the remarkable ability to maneuver a ball of dung that exceeds 50 times its own weight, skillfully pushing it backward with its hind legs while traversing rugged terrain. These balls function as reservoirs for food or as nesting sites for laying eggs, guaranteeing that the upcoming generation will have sustenance. In their quest for direction, dung beetles ascend their spheres, using the sun as their guide by day and the Milky Way as their compass by night. Their unwavering resolve and meticulousness transform a mere task into an act of valor. Under the expansive sky, their small figures carry the burden of the world with a steadfast determination. They are the overlooked architects of the ecosystem, transforming waste into vitality, their quiet resilience resonating with the harmony that unites all forms of life. Leafcutter ants wield their jaws with precision, akin to skilled surgeons at work. In the heart of the Americas forests, leafcutter ants diligently gather pieces of leaves that dwarf their own size. With remarkable precision and coordination, the leaves were cut using jaws so sharp and strong that scientists likened them to surgical scalpels. The mandibles of each ant are infused with zinc and manganese, which serve to harden the edges, bestowing upon them a remarkable metallic strength. They advance in unending lines, lifting their bounty high above their heads like vibrant sails of green. The leaves are not consumed outright. Instead, they serve as nourishment for a concealed fungal garden nestled within the nest. The ants engage in the farming of fungus with remarkable precision, tending to it through trimming, cleaning, and nurturing, ensuring it serves as a vital food source for their colony. Their jaws, intricate and precise, sculpt entire ecosystems through the cycling of nutrients and the careful pruning of vegetation. Observing their efforts reveals a dynamic entity, timeless and relentless, shaping meaning from the woods with each flawless slice. Certain wasps deliver stings to caterpillars, rendering them paralyzed for the benefit of their larvae. In nature's most haunting nursery, certain wasps employ other living beings as vessels for their offspring. A female wasp discovers a caterpillar, strikes with accuracy, and delivers venom that immobilizes the prey without taking its life. She subsequently deposits her eggs upon or within the still host. As the larvae emerge, they meticulously consume the caterpillar's tissues, strategically bypassing essential organs until they reach the final stage. The victim endures, holding on until the cycle approaches its conclusion. The intricate interplay of horror and biology secures the larvae's protection and sustenance. As time passes, the adult wasp breaks free from what had been both its guardian and confinement. It is a timeless design, etched into the very essence of nature, embodying both harshness and precision. Yet within its cold design lies the pure logic of life, continuing through whatever means evolution provides, a testament to the complexity and strangeness that shape existence. Butterflies consume mineral-rich mud to maintain their health. Underneath their fragile beauty, butterflies carry practical instincts that guide them to unforeseen destinations. Along the edges of puddles and riverbanks, a gathering occurs as they drink from the damp soil, in a behavior known as mud puddling. The mud holds essential salts and minerals that flower nectar lacks, yet are crucial for the butterfly's metabolism and reproduction. Males particularly depend on these nutrients to generate more robust offspring, frequently sharing them with females during the mating process. In tropical regions, hundreds of butterflies gather in shimmering clusters, their wings flashing in unison as they sip from the earth. This scene, both modest and exquisite, links the heavens to the earth, hue to nourishment. The butterflies serve as a reminder that even the most delicate existences are intertwined with the physical realm, drawing vitality and resilience from the subtle interactions of the earth below their wings. The cicada's song grows more intense with the increasing warmth of the day. The cicada's song embodies the essence of the sweltering heat. Their song, crafted through the swift pulsations of drum-like organs on their abdomens, intensifies in volume and speed as the air begins to warm. Every pulse of sound is propelled by minuscule muscles that contract in harmony with the temperature. On cool mornings, the song unfolds with a sluggish softness. Yet, by afternoon, as sunlight thickens the air, the chorus swells into a roaring crescendo that envelops the trees. In certain regions, The collective chorus of a million cicadas can produce sounds that surpass the noise of heavy machinery. To humans, it may seem like chaos, but to cicadas, it represents a form of communication, a coded message about mating and territory. The connection between warmth and music transforms their voices into a vibrant gauge, resonating with the very essence of summer's breath. Their chorus resonates not as mere noise, but as the earth gently humming to its own rhythm of warmth and vitality. The brain of a cockroach is distributed across its entire body. The intelligence of a cockroach is not found in a singular brain, but rather in a complex network of nerve clusters that are spread throughout its entire body. These ganglia enable movement, reaction, and the ability to persist even after experiencing significant injury. This design illustrates its remarkable capacity to endure decapitation for days, managing movement and reflexes separately from the head. Every part of its body holds a degree of consciousness, bestowing upon the cockroach an unusual strength and ability to adjust. It possesses the ability to maneuver around obstacles, detect threats, and locate sustenance, even in a state of partial injury. Researchers examining these networks have uncovered astonishing efficiency in the insect's design, where survival relies not on cognition, but on sheer coordination. What appears monstrous to us is merely a remarkable creation of collective intelligence, a life form that thrives through its simplicity and organization. The cockroach exists not merely as an individual being, but as a tapestry of instincts intricately interlaced to create movement. After mating, male bees meet their end almost instantly. Within the serene structure of the hive, the existence of a male honeybee, known as a drone, culminates in selflessness. His sole aim is to unite with a queen, and when that moment arrives, it marks both his victory and his demise. In the act of mating, the drone's reproductive organs separate, leading to his demise almost immediately. The queen persists in her journey, preserving his genetic legacy to nourish the colony for years to come. The drones that never mate are ultimately cast out from the hive as winter draws near, their efforts concluded before they ever truly commenced. This cycle of devotion and death, while seemingly harsh, ultimately fortifies and sustains the colony's strength and continuity. The hive flourishes, its roles harmoniously intertwined in a delicate dance of existence and sacrifice. The drone's fleeting life intertwines with a shared eternity, where the singular fades away, yet the heritage persists, sustained by the harmonious buzz of bees diligently laboring. Certain beetles utilize gas bubbles to rise to the water's surface. In the depths of ponds and the gentle flow of streams, there exist certain beetles that skillfully capture air bubbles, allowing them to navigate their watery environment with precision. These pockets of air cling to their bodies, functioning as small balloons that can be fine-tuned for buoyancy. With a deft adjustment of the bubble's size or position, the beetle demonstrates an impressive ability to ascend or descend with great accuracy. Some species even store these bubbles beneath their wing cases, allowing the air to slowly exchange oxygen with the surrounding water, effectively serving as a natural scuba system. This adaptation enables them to pursue their prey, conceal themselves, and take refuge beneath the surface without the necessity of swimming continuously upward. The glimmer of their bubbles under the light imparts a jewel-like quality, flickering with reflections of the sky and leaves. In a realm of quietude, the realms of physics and biology merge, transforming the essence of survival into a graceful dance of equilibrium and respiration. Colonies of fire ants have the remarkable ability to merge and collaborate over extensive regions. Among the many marvels of insect societies, fire ants are particularly notable for their remarkable capacity to create supercolonies that extend for miles. Under favorable conditions, distinct nests identify each other as relatives through common chemical signatures, uniting to form extensive cooperative networks. In these expansive colonies, the workers navigate effortlessly among the nests, sharing sustenance and knowledge. This cohesion empowers them to command ecosystems, surpassing rivals through sheer abundance and strategic collaboration. In times of flooding, fire ants unite, creating living rafts that serve as floating islands, safeguarding the queen and her brood until the waters subside. Their collaboration intertwines the identities of individuals and the collective, forming a vibrant entity made up of countless minds functioning in unison. Despite the fear they invoke with their sting, their organization stands as a remarkable testament to unity and communication, illustrating how even the tiniest beings can accomplish remarkable feats through collaboration and intent. The Titan beetle possesses the remarkable ability to snap pencils in half using its powerful jaws. In the humid forests of South America, there exists a creature of astonishing strength, the Titan beetle. Measuring almost 20 centimeters long, it stands as one of the largest insects on the planet. The mandibles possess such strength that they can effortlessly break pencils or even penetrate human skin. Despite its formidable appearance, the Titan beetle consumes little as an adult, dedicating its short life above ground primarily to reproduction. The larval stage, concealed within decaying wood, may endure for years, during which it transforms into a tale of resilience. As it finally emerges, its movements are slow and deliberate, steered by instincts that predate civilization itself. The glossy brown shell reflects the faint light filtering through the forest, while its powerful wings produce a mechanical hum. The Titan beetle serves as a testament to the remarkable strength that can be found in the overlooked and often forgotten realms of our planet. Ants possess the remarkable ability to stitch wounds with their mandibles. Deep within the lush jungles of Africa, it is observed that soldiers from specific ant species possess the remarkable ability to seal wounds with their formidable jaws. For generations, indigenous hunters have keenly observed and utilized these ants as a form of emergency medicine. Upon encountering a wound, the ant instinctively clamps down, its mandibles securing firmly around the skin's edges. Once the bite is secure, the ant's body is removed, leaving the head in place as a natural suture. The jaws can stay tightly shut for hours, keeping the wound sealed until the healing process starts. This extraordinary instinct developed to assist injured members of the colony in surviving conflicts and resuming their duties. It is a living demonstration of how evolution refines even aggression into cooperation. Each bite, both fierce and healing, reflects the intricate intelligence of life, adapting to its own needs in endlessly inventive ways. Across continents, butterflies embark on journeys that span generations. Some butterflies embark on migrations so long that no single individual completes the journey. The monarch butterfly embarks on a remarkable journey, migrating from the northern reaches of North America to the serene mountain forests of Mexico. A span of countless kilometers. Along the way, generations rise and fall, each continuing where the last left off. The final generation finds the ancestral destination without ever having seen it before, guided by inherited memory written deep within their genes. The continuity of their flight is a living chain across both time and distance. Researchers continue to explore the intricacies of their navigation, theorizing that it involves a combination of solar positioning, the Earth's magnetic field, and an innate sense of direction. Their migration transforms the sky into an invisible highway of color and purpose, connecting continents through delicate wings that carry the story of survival across generations. Some beetles play dead so convincingly they fool predators. When danger approaches, certain beetles collapse instantly, legs curled, body motionless, as if life has left them. This behavior, called thanatosis, can last for minutes or even hours. Predators often lose interest in unmoving prey, mistaking it for something lifeless or spoiled. Some beetles enhance the illusion by releasing foul odors or stiffening their bodies completely. Once the threat passes, they spring back to motion, as if revived from death itself. This simple act of deception has saved countless lives through the ages. It demonstrates that intelligence in nature often takes forms of stillness and patience, rather than strength or speed. In the quiet theater of the forest floor, a beetle's imitation of death becomes its triumph over fate, a trick of survival, perfected through stillness and time. A dragonfly's wings beat hundreds of times per second. The flight of a dragonfly is one of nature's most mesmerizing performances. Each of its 4 wings moves independently, capable of beating hundreds of times per second. This allows the dragonfly to hover, dart, reverse, and even fly backward with unmatched precision. The mechanics of its flight are so advanced that engineers study them to design new aircraft and drones. Dragonflies can intercept prey mid-air with perfect timing, guided by a nova system that calculates motion faster than any human reflex. To watch one glide over water is to see the physics of grace itself. The whisper of its wings cups through air like a melody of movement and balance. Dragonflies have foamed this way for over 300 million years, unchanged in their perfection. Each one an echo of a time when the first wings turned sky into sanctuary. Termite kings live their entire lives beside their queens. Deep inside the heart of a termite mound lies a chamber where a king and queen live together for decades. Unlike most insects, termites maintain a lifelong partnership between their royal pair. The queen grows enormous as her body fills with eggs, sometimes laying thousands each day. Beside her, the king remains constant, fertilizing the eggs and helping care for the colony. Their relationship is not fleeting but enduring, built upon shared purpose. Around them, workers tend and feed their rulers, maintaining a perfect climate within the mound. The air circulates through a labyrinth of vents, the temperature steady and warm. Together, the royal pair becomes the living heart of an empire that may last generations. In their dim, silent chamber, they embody devotion and stability, a reminder that even in the smallest kingdoms, love and duty can be eternal. Certain flies mimic bees to avoid predators. The world of insects is full of imitation, and few examples are as striking as the flies that disguise themselves as bees. Their bodies are covered in fine yellow hairs, their wings move in familiar rhythms, and their buzzing mimics the hum of a real hive member. Yet they possess no stinger, no weapon at all. This form of mimicry, called Bartian mimicry, protects them from predators who avoid anything resembling a bee. The illusion is so convincing that even humans often mistake them at a glance. Some species even copy the gentle bobbing flight pattern of bees to perfect the deception. Through this borrowed identity, they thrive in safety, feeding freely on nectar without fear. It is one of evolution's most elegant tricks, where survival is achieved not through strength, but through the artistry of resemblance and disguise. Some caterpillars make clicking sounds to communicate. Hidden among the leaves, certain caterpillars communicate not with color or scent, but with sound. By rubbing parts of their body together or tapping their mandibles against leaves, they produce faint clicking or drumming noises. These signals can warn rivals, deter predators, or call for assistance from ants that protect them. Researchers listening closely with specialized equipment have discovered entire acoustic dialogues taking place within trees, inaudible to human ears. The clicks travel through plant tissue like quiet Morse code, carrying messages through branches and stems. For such small creatures, the complexity of this communication is astonishing. Each sound reveals a miniature world of cooperation and defense, a hidden network of voices whispering beneath the surface of the forest. It is a reminder that language exists in many forms, from light and scent to vibration and sound, shared even by the tiniest lives. Bees can detect the Earth's magnetic field. Beyond their vision and scent, bees possess an extraordinary sense, the ability to detect the Earth's magnetic field. Tiny particles of magnetite within their bodies act as natural compasses, helping them navigate between hive and flower with perfect precision. This magnetic sensitivity complements their reliance on sunlight and polarized light patterns in the sky. Even on cloudy days, bees find their way home, guided by invisible forces older than life itself. Scientists have confirmed that bees adjust their orientation based on magnetic cues, proving that their navigation system rivals that of migratory birds. Within their simple appearance lies a world of hidden senses, tuned to the pulse of the planet. Each flight is guided not just by instinct, but by a deep connection to the Earth itself, a dance between biology and magnetism that has endured for millions of years. The earwig protects its eggs like a mother bird. Among the many insects that scatter their eggs and abandon them, the earwig stands apart. A mother earwig guards her clutch with fierce devotion, cleaning each egg to prevent mold and moving them to warmer spots when the temperature drops. She defends them from predators, tending her brood day and night. Even after they hatch, she continues to feed and protect the young until they can fend for themselves. This rare maternal care is a window into the tender side of insect life, where instinct becomes affection. The sight of an earwig sheltering her offspring beneath her body contradicts every cold stereotype of the insect world. Within the dark soil and hidden crevices, her quiet vigilance is a gesture of love as old as motherhood itself, soft and patient, as enduring as the instinct to protect what we bring into being. Some ants rescue wounded nestmates from battle. Among certain ant species, compassion takes a surprising form. When soldiers are injured in combat, their nestmates carry them back to the colony, rather than leaving them to die. Once inside, other ants clean their wounds with mouth secretions that contain antimicrobial properties, reducing the risk of infection. Experiments show that rescued ants have a significantly higher chance of survival. This behavior suggests a level of cooperation once thought impossible in creatures so small. To the colony, each life has value, not as an individual, but as part of the whole. These acts of care strengthen the group's resilience and unity. It is a simple, wordless kindness, written in instinct, showing that empathy is not exclusive to humanity, but arises naturally wherever cooperation sustains survival. In the silent chambers beneath the earth, even the smallest hearts remember how to help one another. The oldest known insect fossils are hundreds of millions of years old. The story of insects stretches back almost to the dawn of life on land. The oldest known insect fossils date to more than 400 million years ago, a time when the world was still covered in vast forests of ferns and towering horsetail plants. These early insects were small and wingless, crawling among primitive vegetation long before the first dinosaurs appeared. Over the ages, they evolved wings, colors, societies, and songs, filling every corner of the planet. Their endurance through extinction after extinction is a testament to adaptability unmatched in the animal kingdom. Each modern insect carries traces of that ancient lineage within its form. To study them is to look backward through time itself into the memory of the earth. They are living fossils of motion and purpose, proof that life's first whispers have never truly fallen silent. And now, as the last wings settle and the hum of the world grows still, let your thoughts drift like soft feathered moths through the night. The forests, the meadows, the quiet soil beneath us, all whisper the same endless story. Life, small and tireless, building, mending, glowing and dreaming. In the dark, their worlds continue unseen, woven together by movement, too gentle for our eyes to follow. Every leaf holds an architect, every patch of moss, a tiny explorer. Close your eyes and imagine the shimmer of beetle shells, the golden pulse of fireflies, the secret murmur of a hive alive with purpose. The earth itself breathes through these delicate lives, a rhythm of renewal that never stops, even when the rest of the world sleeps. And now, as the last wings settle and the hum of the world grows still, let your thoughts drift like soft feathered moths through the night. The forests, the meadows, the quiet soil beneath us all whisper the same endless story. Life, small and tireless, building, mending, glowing, and dreaming. If this peaceful journey brought you calm and wonder, please like, subscribe to Sleep Science Top 1, or share one thought below. What tiny insect fact surprised you most? Your support helps more sleepy souls discover this tranquil space. Breathe deeply, let go, and drift into dreams carried by the gentle flutter of wings and whispers. Sleep well, dream deeply. Good night.